How are you? I hope you are doing great. Yeah, so welcome to EDS, multi-online education platform. Am I audible? All right. Okay. Yeah. So before starting our session, our new chapter about linear equation two variables. So let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features and tools you have. So you have chat option with you in the live session. You can interact with me through chat. Also, there is the live class, so you can ask any doubts to the expert tutors are there. And in the session, you just turn on your camera and turn off your audio. All right. Also, after the class, you'll be provided with the exam preparation material and worksheets also provided to you. If you have any doubts in the after the postcard session, so you just watch the recording videos what we have learned. So without practicing and without seeing all the without learning anything, so you can't get any concept clearly. So that's why practice more questions and try to revise all the concepts. Okay, let's get start our session with the new chapter, that is pair of linear equation two variables. The screen is visible, everyone. Yeah, in pair of linear equation two variable, first in the grade 9, what you learned about the pair of linear equation one variable? What is the general form? Anyone remembered? Anyone remembered? Give me a moment once again. Yeah, the name itself. So there are two variables are there. So we have to write the linear equation. I'm sorry. So let's see how to write the linear equation. Give me a moment. Mm, you have to check the graphically. So this is the chapter overview. I'm showing that, and this is updated version. Yeah. So second concept is algebraic methods and solving a pair of linear equation by doing substitution method, elimination method, and cross multiplication method. So we can do by substitution method and also elimination method. I think elimination method, some part of okay, elimination method is there, and some part of syllabus are deleted. That's why I'm showing that all those things for you. Mm, yeah, so we have only substitution algebraic method. Only two methods are there. Cross multiplication method that deleted in this year. So first method is substitution method, and second method is elimination method. Okay, let's understand. Let's start with our session with the algebraic identities. A pair of linear equation two variable can be represented solved by both graphical method, algebraic method. Okay, so we can once again give me a moment. We can find by pair of linear equation. So by two method. First method is graphical method, and second method is algebraic method. Graphical method and second method is algebraic method. All right. Yeah. So first, let's understand what is the algebraic method and graphical method, each and everything. So let's start our session. Graphical method. Understand here what is the first you need to know about the words consistent, inconsistent. So this is the basics of the chapter. We have to learn all the variables. So first the general form, general or standard form of pair of linear equation two variable, we can write it as, I just write here, there are two variables. So that is ax plus by plus c is equal to 0 plus b c is equal to 0. All right. So here a b c are real numbers. A comma b comma c are real numbers, and c is constant. C is constant as we know that, and x comma y are variables. X comma y are variables. All right. Any other conditions are there? for geometrical representation of, I mean, algebraic representation of linear pair of equation. Give me a moment. All right, let's see what is the inconsistent, consistent, all those things. For consistent, sorry, inconsistent, a pair of linear equation has only no solution. If there is no solution, so we call it as inconsistent. So what I'm saying, so you just mark the each and every important points. All right, and a pair of linear equation has two variables. What are the two variables? That is x comma y. That is x comma y. And here the important point here is, and a and b not equal to 0. A comma b not equal to 0. In this equation general form, a comma b not equal to 0. So we call as general form of linear equation two variables. So this is the general form. All right, ax plus by plus c is equal to 0. Okay, what we are doing now, discussing that inconsistent, consistent. A pair of linear equation two variable which has a solution is called consistent pair. If it is a solution, solution is nothing but x and y value. So it is a consistent pair of linear equation, and it has no solution. We call it as inconsistent pair. All right. A pair of linear equation which has infinite many different solutions. Infinite many different solutions. I'm sorry, something is happened. Okay. So once again, give me a moment. Yeah. A pair of linear equation has infinite many solutions. And through graphically and algebraically, so note that dependent pair is nothing but, so it has common solutions. We call as dependent pair of linear equation two variable. So here is the points. Once again, a line may intersect in a single point. In the case we call as pair of linear equation as unique solution. Unique solution. These are the conditions. Mm, yeah, these 3 points are important. A line may intersect at a single point. In this call, we call as unique solution. Line is parallel to the, in this case, have no solution. Okay, line may be coincident. In this case, has okay. Let's draw this. Let's understand in brief. Okay, there are three types of line. So three types. First type, if you draw the two lines like this. Okay, two lines like this. So this is AB, this is BC, or else CD, whatever. CD. They are meeting at point O here. So they are meeting at one point. So we call this lines may intersect at single point. Single point. In this case, the pair of linear equation has unique solution. So it has unique solution. Unique solution, and the condition here is consistent pair of equation. Consistent. Consistent pair. Now let's move on to the next model. That the lines we can draw indifferently. So let's draw here. If the two lines AB parallel to each other, if they parallel to each other, they are not meeting at any point. So they are not meeting at any point. Let's take an example of railway track. So you can see the straight lines here. Okay, so they are not meeting at any point. So in that case, the solution is, in that case, the lines are parallel. We call as have no solution. Have no solution. Okay, this comes under parallel lines. All right. So this is the intersecting line. Intersecting lines. These are the condition for intersecting line. Now other condition for parallel lines. No solution. Why? Because they are not meeting at any point. So this line is different. This line is different. All right. And inconsistent pair of solution. Inconsistent pair of solution is nothing but what we have learned. There is no solution. Inconsistent pair of solutions. All right. Yeah, this is for parallel line. This is for intersecting line. Now, what is the third line? How can you represent the lines? So if a line overlap each other or else coincident each other, this line is AB, and another line also you you just draw like this. So this is CD, overlap each other. So we called as coincident line. So we called as coincident, coincident lines. Take the notes of the important point. These are the complete textbook part I'm compressing and showing the solution. In that case, the equation has infinite many solution. Infinite many solution. All right. Yeah. And what is the pair of solutions? It is dependent and consistent pair. So here also we'll get consistent pair. I hope you understand with the diagram. Let's see what next. Hmm. Let's understand with the diagrams whether they, yeah, here if you observe the graph here, so this is one x plus 3y is equal to 6 is one equation, and 2x minus 3y is equal to 12 is the another equation. They are meeting at this point, so it is meeting at one single point like this, like this. At meeting at one single point, I mean unique solution, will get constant pair. Let's understand the other diagrams. Let's watch the graphical representation of, yeah, here also the meeting at one point, the two graphs meet at one point, we call as one solution. Any other graphs are there for your understanding? No, only two, three graphs they given. Okay, so this is the actual data. So here A, B, C, A1, B1, C1, they given like equations here. You just compare that A1 by A2, the ratios of equation. Okay, let's understand in deep. Okay, I'll give you equation 2x plus 3y minus 6 is equal to 0. This is the first equation, and second equation is 6x plus 9x minus 18 is equal to 0. So here you just compare the general form, that is a1x plus b1y plus c1 is equal to 0, and I'm sorry, a2x plus b2, so this is y, b2y minus 18, I mean sorry, plus c2 is equal to 0. I'm taking one example for your reference. Now a1 is equal to 2 and b1 is equal to 3. You just say, check the symbols also. C1 is equal to, here plus is the general form, it is minus 6, so you can take minus 6. And A2, the second equation, you'll get 6, and B2, that is 9, and C2, that is minus 18. You just consider the symbols also. Okay. Any equation, whatever the given equation, you just write like this in the ratio A1 by A2, B1 by B2. Okay. Let's solve that. A1 by A2, you just write in ratio B1 by B2, C1 by C2, C1 by C2. All right. A1 by A2, that is 2 by 6 is equal to B1 by B2, that is 3 by 9 is equal to minus 6 by minus 18. So you'll get I'm writing here 2 by 6 is nothing but 1 by 3, and 3 by 9 is nothing but 1 by 3. Minus minus get cancelled. 6 by 3, 18 is nothing but 1 by 3. Okay. If you get only one solution, if you got only one solution, the lines are intersecting. You are getting the same answer, right? A1 by A2 plus B1 by B2. I'm sorry, this is coincide. Let's see the condition here. Yeah, this table is very, 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 very important. So you can write to number of very importance. Okay. Yeah. So here, if the conditions after writing the A1 by A2, so this point is important, nothing else. They are given examples here. A1 by A2 not equal to B1 by B2. So it is exactly one solution. Exactly one solution is nothing but their intersecting lines. Their intersecting lines. So you just write this table on your own. All right. So graphical representation, algebraic interpretation. Algebraic interpretation is nothing but exactly one solution, unique solution like this. Graphical representation, you'll write like this: intersecting line, coincident line. For coincident line, what is the condition? A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to C1 by C2. I hope everyone understood. So that comes under coincident line and infinite many solution. Okay, if we have any space, we just write it here. All right, let's let's prepare the table our own. Yeah, compare the ratio, the pair of equation. First one, a1 by a2 not equal to b1 by b2. So it is we called as intersecting line. Intersecting line, for intersecting line, I already draw the graph. So it is meeting at one point that has only one solution. So that's why you just draw like unique solution or exactly one solution or unique. Unique is nothing but one, right? So that's why you can write exactly one solution, exactly one solution or unique solution or unique solution. All right. Now next format is if the ratios a1 by a2, b1 by b2, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. You just take the these key points. So the line would be coincident line, coincident lines. All right. So now what is the for coincident line? I already draw the graph. For coincident line, how many solutions you have? You have infinite many solutions. Infinite many solutions. I hope you understand. Infinite many solutions. The third one, a1 by a2. Once again, a1 by a2 is equal to b1 by b2, not equal to c1 by c2. We'll solve all the question. Then you can see the representation. How can you write? So we call this parallel line. Parallel line. Now for parallel line, you can confirmed as a railway track. Railway track. So this line is different. This line is different. They are not met at any point. So they are moving like this. So that's why there is no solution. There is no solution. No solution at the moment. They are not meeting at any point. All right. Yeah. So this table is very very important. Let's observe the questions. Yeah, they write the same thing here. Okay. Now the equations are the two equations are you can write like a1x plus b1y plus c1 is equal to 0. The two equations a2x. We have to write this step in first, but somehow you just take the two equations. So the line represented by the equation, these are two equations a1x plus b1y plus c1 is equal to 0. So these are the three conditions. Okay. All right. Let's check with one example. Yeah. Check graphically whether the pair of linear equation uh, is consistent or consistent. Where we learned about consistent. Consistent only for unique solution. Consistent only for unique solution and coincident line. Let's identify the example one. It is consistent or not. Okay. How can you represent it graphically? How can we represent? Let's start with the example one. Let's start with example one. What are the two equations given? X plus 3y is equal to 6. Okay, I'm writing here. X plus 3y is equal to 6 and 2x minus 3y is equal to 12. All right. Now it look like first we have to represent graphically. Okay. What we discuss about a1 by a2, b1 by b2, this is for algebraic representation. Understand carefully. For algebraic interpretation, you just write all those things. For graphical representation, you don't do that type of format. You just do like first you just convert x in terms of y. Okay, x in terms of y. Now x can I write 6 minus 3y? 6 minus 3y. If I transfer 3y to other side, take this as equation 1. Here also 2x is equal to 12 plus 3y. Now x is equal to 12 plus 3y by 12. If we transfer 2 to other side, become 2. All right. Now, mm, okay, let's draw the table. Let's take x value here and you'll get y value. It's up to you. Okay, what are the values you have to take? So if you take x is equal to 0, if you take x is equal to 0, Let's substitute x is equal to 0. Let's take x is equal to 0. Substitute here. 0 is equal to 6 minus 3y. Okay, I'm doing here for your rough part. 0 is equal to 6 minus, or else we'll do like each and every part. Then it would be, these are first term, then you can understand better way. Do one thing. Let's clear this. Mm. For your understanding, I'm writing again, guys. Try to understand. Example 1. Example 1. Why? Because in the first term, you couldn't understand what we are doing. If I do doing directly, then you couldn't understand. That's why I'm writing. Okay, first equation I'm writing here, x plus 3y is equal to 6. Second equation I'm writing here in the next slide. 2x minus 3y is equal to 12. All right. Yeah. Now you can represent if you transfer y to other x to other side. So or else y to other side is equal to x is equal to 3y minus 3y. Can I write like this? Is the equation 1. Okay. Let's take x value. If x is equal to 0, if x is equal to 0, substitute over there. 0 is equal to 6 minus 3y. So transfer 3y to other side, it become plus 3y is equal to 6. Then y is equal to 6 by 3. You'll get 2. You'll get 2. The new point I got, if I take x comma y, if I take x is equal to 0, y value I got 2. I hope everyone understood. You can take your assumption, guys. If I take y is equal to 0, let's substitute in the equation. What is the equation? In the place of y, you just substitute 0. Now x plus x we don't know, that's why I'm writing x. 3 into 0 is equal to 6. So x plus 3 into 0, that is 0. It is equal to 6. X plus 0 is nothing but x. X is equal to 6. Okay, I'm writing the point here. Point x comma y. I got x is equal to 6 and y is equal to 0 I taken. So these are the 2 points I got. Okay, for representing graph, 2 points is enough. If you want to take more points, it's up to you. Okay, let's try with the same format to the next question. Here, if you transfer 3y to other side, it becomes 12 plus 3y. Now x is the only x we need to find. Only x we need to find. 12y plus 3y by 2. If you want to represent like this, it's up to you. Or else do one thing. You just if you, sir, we are good at maths, then we can subtract directly without writing this format. So then it's up to you. The equation 2. Let's take if x is equal to 0. Substitute in the equation. If x is equal to 0, 2 into 0 minus 3y is equal to 12. 2 into 0, that is 0. Minus 3y is equal to 12. 0 minus 3y, that is minus 3y is equal to 12. Then y is equal to, so 12 by minus 3, you will get minus 4. Now the new point I got, x comma y, x I taken 0 and y I got minus 4. If you want to substitute like this, it's up to you. Or else you can convert like this. In the textbook, they converted like this, 6 minus x by 3. It's up to you. If you want to direct substitute like this. Now, if you take y is equal to 0, yeah, you can assumption any value. X is equal to, you can take 1000, y is equal to 10,000. It's up to you. It's your mathematical knowledge. All right. Let's substitute y is equal to 0 in the equation. 2x we don't know, and 3 into in the place of y, it is equal to 0. Now 2x, 3 into 0, that is 0. Minus 0 is equal to 12. 2x is equal to 12. Now x is equal to 2, transfer to other side, it become 12 by 2. After cancellation, I got 6. Okay, now what is the new point I got? X comma y. That is x 6 I got and y is 0. Why? Because y I taken 0. Okay, we got 2 points here. Now next step is you just represent that in a graphical way, in a graphical representation. Let's do it here. Okay, I think everyone knows how to take the graph. Okay. So you just take the graph like this. So this is positive y and this is negative y. This is positive x. This is negative x, x minus. The intersection point, we can take it as a origin. All right. We can take it as origin. All right. Let's take some values here. Okay, 1, positive 1, 2, 3, 4, 5, 6, 7, 8, like this. And here, -1, -2, -3, -4, -5, like this. And here, -1, -2, -3. You can take units like this. And here, positive values, that is 1, 2, 3, 4, 5, 6. It's up to you. Okay, so what are the points we got? Here x plus 3y, x plus 3y is equal to 6. We got 0, comma 2. Let's represent 0, comma 2. 0, comma 2. So 0, comma 2 is nothing but x value 0, y value 2. So we can represent here 0, comma 2. All right. I'm doing well the first equation. And another point is 6, comma 0. Another point 6, comma 0. 6, comma 0 is nothing but y value is 0. That's why you can represent 6, comma 0 here. Now let's join these two values, two dots. You just draw. Okay. I didn't get the proper line. I'm drawing again. All right. Yeah, you'll get the straight line like this. You'll get the straight line like this. Name this straight line. Name this straight line as, what is the equation 1? X plus 3y is equal to 6. You just represent this straight line as x plus 3y. Okay, first we'll draw another line, then we can understand. Second equation we got 0, comma minus 4. 0, comma minus 4 is nothing but here it is there. 0, comma minus 4. And another point 6, comma 0. 6, comma 0 again. 6, comma 0. 12 by 2. Give me a moment. Okay, whatever. So we got the 6, comma 0. 6, comma 0 is, again we have to look at this one. All right. So now join these 2 points. Okay, do one thing. So I just change the color for your representation of, I just represent with another color, then you can understand better way. Okay, so the second line I'm taking as 0, comma minus 4 here. 0, comma minus 4, right? Second line values 0, comma minus 4, 6, comma 0. 6, comma 0 we can represent again here. 6, comma 0. 6, comma 0. All right. Now let's join these 2 points. You just join like this. Okay. So this line, first line, it is x plus 3y is equal to 6. X plus 3y is equal to 6. This line. And the second line, that is 2x minus 3y is equal to 12. 2x minus 3y is equal to 12. So this is second line. Okay. They are meeting at the point, this point. They are meeting at this point. So 6, comma 0 is they are intersecting at one point. That's why we can confirm it as the, so observe carefully, they are meeting at 6, comma 0. That's why we can, so x is equal to, we have observed that there is a point 6, comma 0 is both common to both the lines AB and PQ. So that's why the solution of the pair of linear equations is x is equal to 6. X is equal to 6 and y is equal to 0. The given pair of is consistent. So the line we can conclude as unique solution or else exactly meeting at one point. Exactly meet at one point. One point or else unique solution. It's up to you. For unique solution, we call as exactly one solution or unique solution we call as intersecting line. So this graph is intersecting line. It is intersecting line. Intersecting at 6, comma 0. Intersecting at 6, comma 0. So you just do like this. I'll explain step by step again from the first step. Okay, they given two equations. Remember carefully. They given two equations. Two equation, it's up to you whether you have to change or not. So you just take x is equal to 0. Okay, sir, why you are taking x is equal to 0? We can take any other value. It's up to you. You can take 1000, lakh, 1 lakh, 2 lakhs like this. X is equal to 2 lakhs. So if you take the bigger numbers, you'll get the bigger value. So that's why if you draw the graph, it would be complicated. That's why I'm taking smaller value. If you take x is equal to 0, y is equal to 2. If you take y is equal to 0, x is equal to 6. All right. Now you can draw the table 0 comma 2 and 6 comma 0 another point. Same way for second equation. If you take x is equal to 0, you'll get 0 comma 4, and for y is equal to 4 we got minus 4, and x is equal to 6 we got. After getting the 2 points, I just represent in the graph. This graph is different. This graph, I mean this is the separate line, this is the separate line. The two lines meeting at point 6 comma 0, 6 comma 0. Okay. All right. So that's the first question. Now let's start the second question. Mm, okay. Here what they did in the question, they given 5x minus. Okay. The same way, same procedure. Example 2, right? Example 2. Let's do the example 2. The equation, first equation 5x minus 8y plus 1 is equal to 0. Okay. This is equation 1. Equation 1. Second equation, similarly what we did in the previous question, I am taking here 3x minus 24 by y minus 24 by 5 into y plus 3 by 5. Here what they did, so 24 by 5 and 3 by 5 in the previous question, so it is the normal numbers 5, 8, 1, but here they are in fraction, so that's why you just multiply with, we want to remove 3 by 5, multiply with 5 by 3, the whole equation you will get 5 by 3 you will get. So let's multiply 5 by 3 into 3x minus 24 by 5. Okay, 5 by 3 first, right? 5 by 3. I'm multiplying 5 by 3 with the each and every equation. So 24 by 5 into y plus 3 by y. Okay, first I'm writing 5 by 3. Then you are able to understand 5 by 3 into 3 by 5 in the question. Observe carefully. Observe carefully here. 3 3 get cancelled. Why? Because both are multiplication. 5 5 get cancelled. And 5 5 get cancelled. 3 3 get cancelled. And 3 8s are. Can I take 3 8s are? Now what we left with? I left with here 1 into x, that is x, 5 into x, 5x minus, here I got 8y. If not, all the everything is cancelled, you'll take it as 1. This is the actual question. This is the actual question. So we converted like this. Now this is a fresh equation, that is equation 2. You can take the fresh equation. I hope everyone understood. All right. So we got the two equations. Let's solve it by taking x and y value. Let's take if x is equal to 0, if x is equal to 0, substitute over there 5 into 0 minus 8 into, okay, we don't know why, I keep 8y plus 1 is equal to 0. 5 into 0, that is 0, minus plus 1 is equal to 0. Minus 8y, if we transfer to other side, it becomes plus 8y is equal to 1. Now y is equal to 8 here, multiplication, if we transfer to other side, it becomes division, 1 by 8. All right. They are taking the same values or any different values. Okay, 1 by 8. Okay, we are getting in fractions, right? Mm, okay, what are the values they are taken? Y is equal to 2x minus 2r. In the question. What is the equation they given in the question? 5x minus 8y. Okay, equation same as the equation 1, 5x minus 8. Okay, both equations we got the same value. Observe carefully here, 5x minus 8y plus 1 is equal to 0. Here also 5x minus 8y plus 1 is equal to 0. Do one thing, they are two the same equation. For the same equation, equation 1 is same and equation 2 is same, and they are constant each other. Why? Because we got the same value. Here also 5 by 1 by 8 for constant value. So they have infinite many solutions. Infinite many solution. Plot the few points on the graph and verify it yourself. Okay. They given to us how to solve. Okay. So let's solve. Why? Because we already started, right? Uh, okay. Let's take the point. Now if y is equal to 0, If you substitute y is equal to 0, now 5x minus 8 into 0 plus 1 is equal to 0. 5x 8 into 0, that is 0. 0 plus 1 is equal to 0. Now 5x is equal to 5x plus 1 is equal to 0. 5x is equal to, if you transfer 1 to other side, become minus 1. X is equal to minus 1 by 5. Okay, we are getting in fractions. That's why let's write the points here. X comma y, the same what we did. Here we taken x is equal to 0 and y value we got 1 by 8. 1 by 8 can we represent in, okay, 1 by 8 value generally, 1 by 8 is nothing but 0.15. If you do in calculator, 0.125. And yeah, in this point, x comma y, x comma y. Here y taken 0 and x obviously 1 by 5 is nothing but, let's do 1 by 5, 0.2. So minus 0.2. Okay. The same procedure. Here also we got the same equation. If you take x is equal to 0, if x is equal to 0, then you'll get y is equal to, why? Because the same equation, 5x minus 8y plus 1, 5x minus 8y plus 1. So if you take x is equal to 0, y value you'll get 0.125 or is 1 by 8, whatever. If y is equal to 0, you'll get x is equal to, what is the value we got? Minus 0.2, minus 0.2 comma 0. Okay, let's draw the graph. Ignore the diagram. Here x and x minus, positive y, negative y. Okay, what are the values we got? 1.25. All right, let's take the values. 1, okay, here intersection 0, 1 2 3 4 5, like this. 1 2 3 4 5. And here also minus 1, minus 2, minus 3, like this. Minus 1, minus 2, minus 3. You can take in scale the each and every point. Okay, what are the values we got in the first equation? First equation, second equation, same we got the 0.01. X value 0, y value 0.125. X value 0, y value 0.125. 0.125, it is lies between 0 and 1. Okay, 0.1. So it is lies between somewhere here. So that's why. So we can take 0.125. And second point, if y is equal to 0, x is equal to minus 0.2. Minus 0.2. Minus 0.25. Yeah, minus 0.2. Minus 0.2, it lies here. Why? Because y is equal to 0. Minus 0.2. Okay. Okay, I'm joining the lines, both lines. So this is equation, what equation? 5x. 5x minus 8y plus 1 is equal to 0. There is no use we draw the graph. Why? Because both are coincident. The second graph, second equation, what we get the values, x is equal to 0, y is equal to 0.125. Again, you are getting here 0.125, 0.125, and minus 0.2. Again, you are getting here minus 0.2, 0 comma minus 0.2. All right. Now, if you join the same graph, the 2 points, so it is overlapping each other like this, overlapping each other like this. So you can name it this graph as, again, 5x minus 8y plus 1 is equal to 0. Both are same equation, but that's why the graphs are overlap each other. You get the same line on the same graph. Okay, that's why they didn't do anything. So plot they given like plot few points and graph and verify itself yourself. They given like this. All right. Yeah, let's solve the next question. Champa went to a sale to purchase some pants and skirts. Okay, she want to purchase some pants and skirts. Champa is a female, right? Yeah. When her friends asked her to how many of each she had bought, she answered that number of skirts is two less than the twice the number of pants. Okay, first we'll just write the conditions here. First condition, what she said. This is example 3, right? Example 3. Condition 1. Condition 1, she said, first condition, the number of skirts, the number of skirts is 2 less than, is 2 less than, 2 less than twice the number of pants. Twice the number of pants. So this is the first condition. I'm writing the second condition at another point, or else I just write it here. Okay, I'm writing here the condition 2 at here. Condition 2. What is the second condition? She said. Also the number of, what is it? Number of skirts is 4 less than. Number of skirts. Okay, do one thing, better to write at another page. Then you can understand better way. C2, condition 2. The number of skirts is 4 less than. Is 4 less than. Number of skirts is 4 less than 4 times the number of pants. 4 times the number of pants. Okay, I'll ask you one question. Okay, let's see the first condition. I'll ask you one question. You know the number of skirts and number of pants, how much she purchased? No, right? So let's assign the variables. The number of skirts, we don't know. Let's take it as X. Okay, here they taken Y, the variable. So let's take Y, and the number of pants, you can take X. All right. Yeah. Now understand the condition. Now understand the condition. The number of skirts is the number of skirts is nothing but Y we are assigned. So Y I'm writing is nothing but is equal to 2. 2 less than is nothing but, so 2 less than is nothing but you just write less is nothing but we should write the minus symbol. Minus symbol, twice the number of pants. So twice the number of pants. I hope everyone understood. Okay, for your simplification, for your understanding, I'm writing again. Understand carefully. Number of skirts. I'm stressing each and every point. Number of skirts, we don't know. That's why I'm taking is. Is nothing but is equal to. Ignore the 2 less than. First, twice the number of pants. Twice is nothing but 2 times. Number of pants, we don't know. That's why we can take. And how many less than? 2 less than. So we just subtract 2. Now y is equal to 2x minus 2 is our first equation. I hope everyone understood. The same thing here. We don't know number of skirts. We taken already number of skirts is y and number of pants is y x. Now understand number of skirts is, so that is y is nothing but is equal to, okay, ignore the 4 less than, we just do that 4 times number of pants. 4 times is nothing but we should multiply with x. Number of pants is x is right, and 4 less than we should subtract 4. So y is equal to 4x minus 4 I got. I hope everyone understood how to frame the equation. Yeah. So after framing the equation, so you can assign the, okay, if you take x is equal to 0 here, if you take x is equal to 0 here in this equation, the same procedure. If you want to draw the graph, you just take x and y value. If you take x is equal to 0, y is equal to 2 into 0 minus 2, then y is equal to 0 minus 2, that is y is equal to minus 2, y is equal to minus 2. All right. So I just write the point here, x comma y. I got the new point, that is 0 comma minus 2. Okay, let's take y is equal to 0 now. Let's try with y is equal to 0. So 0 is equal to 2x minus 2. So minus 2 if we transfer to other side, so 2x is equal to 2, x is equal to 1 I got. X is equal to 1. Now the new point I got x comma y, that is 1 comma 0, 1 comma 0. So these are the 2 points I got. The same equation for if you just do the x is equal to 0 here. This is equation 2. This is equation 2. This is equation 1. Okay, already write it equation 1. Yeah. So now let's do it. If x is equal to 0, y is equal to y is equal to 4 into 0 minus 4. 4 into 0 is nothing but 4. Sorry, 0 minus 4 you'll get. The new point I got 0 comma minus 4. And if y is equal to 0, y is equal to 0 is equal to 4x minus 4. So 4x is equal to 4. We transferred other side, it become plus x is equal to 1 I got. So I got 1 comma 0. Okay, we got the 4 points. You just draw in the graph like this. Okay, this is y plus, this is y minus x plus. Okay, let's substitute the values. So here 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and minus 1, minus 2. So minus 1, minus 2, minus 3, minus 4 like this. I'm drawing the raw graph. Okay, let's first equation. So we'll get 0 comma minus 2. 0 comma minus 2, it is located at here. 0 comma minus 2. 0 comma minus 2. And the second point 1 comma 0. 1 comma 0, it is located here 1 comma 0. So let's join these 2 points. So this line is we called as the first line, that is y is equal to 2x minus 2, y is equal to 2x minus 2, y is equal to 2x minus 2. And let's draw the second one. Second point 0 comma minus 4. 0 comma minus 4. Okay, minus 4 something here. 0 comma minus 4. And 1 comma 0. 1 comma 0. I think here 1 comma 0. Okay, let's join these 2 points. So here also the two graphs, this is the graph of y is equal to 4x minus 4, y is equal to 4x minus 4, this line. Okay, red color, they are intersecting at 1 comma 0. That's why both are intersecting line at 1 comma 0. Okay, so this is what they said. The two equation, they intersecting at 1 comma 0. The two lines intersecting at 1 comma 0, x is equal to 1, y comma 0. Okay, so the number of pants she purchased 1, and she did not purchase any skirt. Why? Because in the previous one we taken x is equal to number of pants and shirt. Like, yeah. So all right, I just end up here, guys. Yeah. So try to practice more question and revise all the topics. Let's start with the exercise sum 3.1 the next class. Okay. Bye bye. Have a good day.